Okay, so first question, which glass holds the most water? Which glass holds the least? I don't have any objects that look like, especially that last one. But you should be able to tell maybe by how dark the water is, if it's all the same, which one's the most dark. Maybe that's more dense, or maybe it's got more food coloring. It's tough to know. But without seeing these, it is tough to have a visual on that. So I did do some measurements on the next page. Anybody know what a graduated cylinder is?
Yes.
What is it?
It's a cylinder that you put stuff in.
Yeah, usually they're about a foot tall or so. A lot in the science lab. So I'm not sure if you used any of that, but I would like you to write these numbers down. So we just dropped some marbles in that. We started at 60 milliliters. Put in 3. Put in 7. Put in 11. Those were the measurements. So I'd just like you to jot those down, and we're going to talk about that here and answer some questions going forward. Okay, so let's answer questions then. Number 2. What is the volume? What is the volume after you add X objects? So the question is, how much is the water going up? In this case, I'm starting at 60. Started with 60 milliliters, and I got to figure out how much it went up. Just like those cups that we just talked about stacking, how much did the water go up? Well, it went from 60 to 71. That's an increase of how many milliliters? 11 in how many objects? So I gotta take 11 divided by 3, please. Somebody's got a calculator handy. That's gonna tell us how much each object went up. Even? 3.6 repeating. So we're gonna just call it 3.7 then per object. Okay? We'll say 3.7. You put 3.6, that would be fine. 3.7 milliliters per object on average. So if you want to make the water reach the highest mark on the cylinder, how many objects would you need? I told you it was a 100 milliliter graduated cylinder. So how many objects would you need? Well, what do we know about 11? Yeah, it's too much. So somewhere between 10 and 11 objects. All right, 11's too much. 10 won't be enough. 10's going to be short, but somewhere between there. I think that is good enough for us there. Plot and label the points that follow your measurements. All right, so those points, I gave you 4 of them. Please put them on the graph. It does say plot and label, so you should have those points labeled of what numbers are being plotted there as well. And then do the best you can with connecting them. Question 5 says they should line up. Use a ruler to connect them, or whatever you got. Compute the slope. All right, we've talked about that quite a bit. The slope, rise over run. You can pick any 2 points on here and figure out the slope. I always think it's easier to use one with a 0 in here. So we're going to figure out the slope from this point over to this one. So it's rise, how far up did it go, over, how far over to the right it went. So vertically, we're talking volume, right? That's my y's. It went from 60 to 71. That is a rise of 11. And then I went over 3, and I started at 0. So 11 divided by 3, you already told me what that was. Said it was about 3.7. Now what does it mean in this problem? 3.7 what? Per? Per object. 3.7 milliliters per object. That is what that means. That is how much the water went up in a graduated cylinder per marble you dropped in. All right, somebody other than Sienna needs to answer what the vertical intercept is. And what's it mean? Othniel, what's the vertical intercept? What is the y-intercept? Where does it cross the y-axis? Want to call a friend? Who? Parker. Parker, what's the y-intercept?
I have no idea.
Where does it cross the y-axis?
Can I phone a friend?
Okay.
That's Louisiana.
Nope, can't pick Sienna.
Ian. Is it 60?
I don't know. Is it 60, Ian?
Yes.
Yes. All I'm asking is where it crosses this line. Othniel, where it crosses this line? 60. All right, Ian. What's it mean?
What?
60 what?
Milliliters.
Yeah, that's where we started at. That's how much water started in our graduated cylinder. Our initial amount. Before any objects were added. All right, we're going to skip the are you ready here and go right into the final question. That says, what is the slope? Okay, we'll do one of those together. Which one do you want to do together, Adam? A, B, or C? B? All right, we're going to do B together. Okay, the vertical change, that's how far change is going up and down, right? Up and down, that's comparing these numbers at the end. That's our y-coordinate. So it went from 1.5 to 3.5. That is a change of 2. 3.5 minus 1.5 is 2. Horizontal change is my x-coordinates, how much those change going left to right. It goes from 2 to 10. That is a change of 8. So my slope, rise over run, is 2 over 8, which can be reduced to 1 over 4. Okay, rise over run. Subtract the y's over the x's. Okay, why don't you do A and C then? No, you're just not playing a game because I'm walking around. All right, letter A. Othniel. Vertical change. 9 minus 3. 6. Horizontal change. 3. Slope, which reduces to 2. Yeah, 6 divided by 3 is 2. C. Taylor. Vertical change. 75 minus 35 is 40. Horizontal. Slope, which is?
2.
Yes, let's go. Correct. Describe a procedure for finding the slope between any 2 points of a line. Okay, it can be described by the formula we've mentioned quite a bit. You subtract the y coordinates, you subtract the rise, you subtract the vertical change, however you'd like to say that, over the run, over the x's, over how far left and right it goes. So for the last one, does not give us points there, but could you write an expression? Could you write an equation to get the slope? I'll give you 30 seconds. See if you can do that based on those points. Changing the y's over changing the x's. Adam, what do you got?
Oh, I don't know.
I know. I saw it. What do you got?
Like,
Like?
V.
I gotta write that?
Yeah.
Like?
Oh. Like V minus T. Yeah.
V minus T, something like that. That's right on. That's a lot of extra stuff. I like V minus T. Yeah, that looks good, right? Subtract the y's. V minus T. Just like you did on the previous problem. Over?
Oh,
I already got that.
U minus S.
U minus S, yes. There it is. Subtract the y's over the x's. Doesn't matter if they give you numbers, letters, it don't matter. Process is the same. Okay, remember, if your line is going uphill, you're going to have a positive slope. Keep that in mind. If it ever is going downhill, it's going to be negative. Okay, go in the same order. If I do V minus T, I got to do U minus S. That's the most important thing. All right, take a peek then at the homework assignment starting on page 67. I do not think there's anything too crazy here. 2 is a review from Unit 1, reflections, rotations, dilations. Question number 3, that one's going to be different for everybody. Create a graph that shows 3 linear relationships. That means you're going to have 3 lines on there. And make a note of that. 3 different lines. Has different y-intercepts, so you pick the y-intercept. It's up to you. Here's our slopes, and write the equations. So I need 3 equations. 3 lines, it tells you the slope to use. Use whatever y-intercept you want. Okay, that one's going to be up to you. And there is a number 4 on the next page as well. Write the equation. You should be able to get the slope and the y-intercept right from that graph. So just 4 questions today. Make sure that book is up to date for the quiz tomorrow. Okay, quiz tomorrow over 1 through 7.